All right, so we are starting a new subject here. We're going to talk about probability. And probability is really the main tool that we use in statistical analysis. This is sort of the gears that make everything work. So this is a very important topic. So this first short video is going to go over just terminology and some definitions that we want to get straight before we start actually looking at formulas and different types of probabilities. So I have this fancy pointer here that I'm going to use. Look at this. Oh yeah, look at that. That is some fancy shit right there. This is high class education. So let's look at some of these things. So probability basically has to do with performing experiments that have n equally likely random outcomes. We call those outcomes events. All right? So I'm going to sit on this side. We call those outcomes events. Examples of these types of experiments: rolling one fair die, right? 2 dice, 1 die. 6 equally likely random outcomes if it's a fair die. Tossing a fair coin, right? Heads or tails. 2 random outcomes. Now, of course, that is ignoring the famous Twilight Zone episode from the 60s where the guy flips the coin outside his office one day and it lands on its side. If you haven't seen that one, it's a good one. I won't tell you how it turns out, but we're going to ignore that probability and say that there's only 2 equally likely outcomes. Picking a card from a full deck, 52 outcomes. So this is an example. These are examples of events. Rolling a fair die is an event. Tossing a fair coin is an event. No, I'm sorry. Yes, it's an experiment, and the outcomes are the events, right? The outcome of rolling a 1, the outcome of rolling a 2, and so on. The outcome of flipping a coin and getting heads, the outcome of flipping a coin and getting tails, and similarly for picking a card. So picking a card, tossing a fair coin, rolling a fair die, examples of experiments, the outcomes, examples of events. So again, we just have that written over here. And another thing you want to be familiar with is something called a sample space. The sample space are all the possible outcomes in that experiment, all the possible outcomes, all the possible events that consist of that experiment. So again, for a coin, the possible outcomes are heads and tails. For rolling 1 die, the possible outcomes are the numbers 1 through 6. And for picking 1 card from a full deck, the sample space, all the possible outcomes are all those 52 cards. All right, so we define probability as a measure, a numerical measure. We're going to give it a numerical measure, and that numerical measure is always a number between 0 and 1. Okay? So it's a numerical measure of how likely one outcome is among that entire sample space of equally likely outcomes. And it's always a number between 0 and 1. So I really want you to get the terminology straight here. This is how we want to see things written out. Capital P for probability. Okay, if you want to put a little r there for probability, that's fine. I just use a capital P. The event goes inside the parentheses here, not the number, unless the outcome is a number, but not the probability. A lot of people will, when they give an answer and say that the probability is 1/2, like probability of flipping a coin and getting heads is 1/2, a number between 0 and 1. You can write that as 1/2 or 0.5. Technically, percentages are not numbers between 0 and 1, but we can use percentages also. We can say 50% is equal to 1/2 or 0.5. I will allow percentages for probabilities, even though they don't strictly fit the definition of being a number between 0 and 1. They are clear about what the probability would be. So for this, I don't want to see p and 1/2 here. That is not correct. Or p equals a number. That is not correct notation. This is correct notation. I really, really want you to use correct notation. These are little things, these are details, these are fundamentals, which I really want you to get straight, because that's where the importance is in any subject, in the details. So the probability of a certain event equals a number between 0 and 1. Okay, not this, not this. And like we said, we got a couple examples of that here. We went over this one. Probability of getting a 2 on rolling one die. If it's equally likely outcomes, well, that's one number out of 6 numbers. So the probability is 1/6. You could turn that into a decimal. You'd have to round it to a desired decimal point. Or you could give it as a percentage. I believe that percentage is somewhere around 16 2/3, something like that. So fractions are preferred if it's small numbers like this, 1 out of 6, 1 out of 2. It's very clear what's going on there. Probability of the ace of spades. Well, there's only one ace of spades out of 52 cards. The probability is 1 out of 52. Now, just as an aside there, if you said the probability of any ace, well, there's 4 aces in the deck out of 52 cards. Always try to simplify your fraction. In this case, 4 out of 52 becomes 1 out of 13. All right, so there's a couple more things we want to make sure we go over here. And we'll be using these in formulas in the next few videos. This video is just the terminology and the introduction to what probability is, how we write it out, and these things. Sometimes we're going to want the probability of A and B. All right, we call this an intersection of two events. We use this symbol. I always remember this as an A without the bar. Right, so for and, right, and we use this symbol. It's an intersection of two events. The intersection of two events is the probability that both happen. They both have to happen. Okay? Only when both happen do we say that the intersection of two events is occurring. As opposed to one or the other happening, we use this symbol for union. So a union of two events, we use U, or this symbol that looks like a U, to represent A or B. We're saying A is an event, B is an event. These are undefined events. These are just general events. Probability of A or B is the probability that either one of those happens, or both. If they both happen, then one or the other did happen, and it fits the definition of a union. So I want you to get clear on what an intersection is. Means both the events have to happen, or a union of two events is where one or the other happens. Okay, one last definition here, and we'll end this video. Conditional probabilities. Conditional probability is written like this, where we have a line between two events. The event that comes after the line is the condition. Okay, so here we're saying, we read this as the probability of event A happening given that event B has already happened. So think of it as the probability of event A happening conditioned on the fact that this event B has already happened. All right, so this introduction, I just want you to know what probability is, how to express a probability, event, and outcome, what a sample space is, what an event is, how to write out your probabilities. We'll get into unions and intersections in the next section when we talk about the multiplication rule and the addition rule, and conditional probabilities will come into play along the way. All right. See you next time.